Ladies and gentlemen, welcome to this short video on binomial experiment. So, what is a binomial experiment? A binomial experiment consists of a fixed number n of repeated independent trials with only two possible outcomes at each trial. And these two possible outcomes at each trial, one of them we call it a success, and the other one we call it a failure. So the probability P of success on each trial does not change. That is very, very important for you see, bi means two. So an experiment with two possible outcomes, we call it a binomial experiment. The probability P of success on each trial does not change. The probability Q on a trial does not change as well. So the events success and failure are mutually exclusive and exhaustive. In other words, they make up the entire sample space. So the probability of P plus the probability of Q must be equal to 1. That is the meaning of exhaustive. Now, what are the examples of a binomial experiment? Now, if you flip a coin 10 times, so let's go back a bit. We've got a fixed number n of repeated independent trials. What do we mean by independent trials? When you flip a coin first time, and suppose you get a head appearing, when you repeat the same experiment in the second trial, the fact that you obtained a head in the first trial does not influence you getting a head or a tail. So that is what we mean by independent trials. The next trial, the outcome of the next trial is not dependent on what you obtained in the previous. So here, when you flip a coin 10 times, this is an example of a binomial experiment because there are exactly two possible outcomes. It's either you get a head appearing or a tail appearing. And the probability of getting a head, we know it is half. That of getting a tail, we know it is half. So you can see that the probability P and the probability of Q is equal to 1. It is actually mutually exclusive because you cannot get, once you get a head, it means you will not get a tail. So that is an example of a binomial experiment. Guessing the correct answer from 6 multiple choice questions. It's an example of a binomial experiment. In what sense? Suppose you don't know completely. You are just guessing. Let me assume that question 1 has got A, B, C, D. There are 4 choices. So, and there is only one correct answer. It means the probability of getting it correct, it will be 1 out of 4, where we take each question to be a single trial. So in this case, it means we are going to have 6 trials. The probability of getting the correct answer being 25% because there are A, B, C, D. There are 4 choices to be made, and there is only one of those choices being correct. So choosing a ripened watermelon from 10, given that 60% of them, sorry, here this is 50% of the melons are ripened. So here there are no betweens. It's either the melon is ripened or the melon is not ripened. So this is a binomial. Selecting a smoker from 20 thieves, given that 90% of them smokes. So when you choose a person, it's either he smokes or he does not smoke. There is nothing called the partially smoke or what. It's either you are a smoker or you are a non-smoker. So every time we choose, that it becomes a trial. So 90% of them smokes. It means the probability of getting a smoker is 90%. The probability of not getting a non-smoker is 10%. So this is a binomial experiment. Choosing a violent man from 10 men, given 40% of men are violent. I think the same explanation makes it binomial. So what I want you to do, just think of so many examples that constitute a binomial experiment. Now, what is a binomial distribution? The probability distribution of the number of success x in the any trials of a binomial experiment is called a binomial distribution. What a binomial distribution is actually a function for generating probabilities. So you can see the probability distribution is given by. So here what it means is that probability x equal to a certain number. For example, we can say probability of, let me go back so you understand this. In the example, selecting a smoker from 20 thieves, given that 90% of them smokes. So out of 20, n is equal to 20. So what is the probability of choosing 3? So our R will be equal to 3. We define the random variable x to be the smoker now, number of smokers. So probability number of smokers, which is x, is equal to 3 out of 20 will be given by 20, choose 3, probability 0.9 to the power 3 times 0.1 to the power 7, 20 minus 3, which is 17. So this is what it means. So this is the function that you need to master, this one. For a binomial distribution, we generate probabilities using this function, and this is very, very important. Probability x equal to a certain number is equal to, out of the number of trials, choose that number with the probability p of success to the power r q to the power n minus r. This is very, very important. And n choose r is the number of ways of selecting r elements out of n. I'm sure this you need to understand, and it is given by this formula in factorial notation. But on your calculator, you can easily get this, so you don't need to memorize this. But what you need to understand is how to use this function to generate binomial probabilities when given a binomial probability situation. So with me here, I have an example, a numerical example number 1. A fair coin is tossed 4 times. In other words, our n is equal to 4. Find the probability of getting 3 heads. So you see here, let me escape here. So we are given, in this case now, n is equal to 4. The random variable x is the number of heads obtained. So x follows a binomial 1/2. So normally we write x follows a binomial distribution in number of trials, and then we put the probability of success here. So probability x equal to 3. This is exactly what we are asked. Find the probability, find the probability of getting 3 heads. That is what we are asked. So probability, our R you can see is equal to what? 3. So we are saying out of 4 trials, we are going to choose 3. Half is the probability of getting a head to the power 3, 0.5 to the power 1. You see, we are using the formula, so the probability distribution formula, and then when you punch this in a calculator, we get this answer. Now we move on to the last one, example 2, which I did not work out, and I expect you to work out. So what I want you to do, just to go through this, I will post a number of problems on our Moodle platform that I want you to go through and understand how to use the binomial distribution. A lemon grower estimates that 60% of his crop is ripened. Suppose a random sample of 5 melons is selected. Determine the following probability. Exactly 1 melon is ripened. So in other words, the number of melons can be modeled by a binomial distribution. In other words, we can simply write our number of lemons, x follows a binomial. In other words, we just write x, where we define our x to be the number of melons, will follow a binomial. Then how many times it will be? 5 times, because we are with what probability of success? 0.6, that is the 60%. So with this one, you can actually use this to determine the probability that for the first, for example, exactly 1 means x is equal to 1 is equal, x is equal to 1. So out of 5, we choose 1, 0.6 to the power 1, 0.4 to the power 4. Then that we put it in our calculator and we get our answer. So when we move on to the next, more than 2 are ripened. More than 2 means we are actually looking for the probability that x is greater than. You see, more than 2 means the x is greater than 2. That is what it means. So less than 4 means probability x is less than what? Is less than 4. You see, probability x is less than 4 is the same as the probability x can be 0, is equal to 0. plus probability x is equal to 1, and so on and so on. So we proceed here to say plus x is equal to 2, x is equal to 3. So here plus probability x is equal to 2, and then we proceed. But you see, to expand probability x is equal to 0, we need to use the binomial distribution with r equal to 0, binomial distribution with r equal to 1, binomial distribution with r equal to 2. So this is what we are, then we evaluate this using the binomial distribution. We get the number here, we get the number here, we get the number. Then that will give us the probability less than 4. And it's straightforward. I don't think this is a problem. So at least 2 are ripen. At least 2 are ripen means we are looking at the probability, probability that x is actually less than at least 2. At least 2 means x is greater or equal to 2. So in other words, it means x is greater than 1. X is greater, this is at least 2. At least 2, it means greater than 1. So the next number is from 2 and above. Or we say x is greater or equal to 2. Then we put 2 here. It means at least 2. If I say 2 people come, at least 2 people must come. In other words, I'm saying 2 and above. So thank you very much, colleagues. What I'm going to do, I'll put a number of questions, but practice makes perfect. Binomial distribution is very simple and straightforward. So what you need to know, what is a binomial distribution? A binomial distribution basically is the probability distribution of the number of success x in the any trials of a binomial experiment is called a binomial distribution. Thank you very much. Enjoy.